Okay, Assalamualaikum and hello guys. So today we are going to learn the last chapter, that is polymers. Okay, saya dah buat nota ni cantik-cantik. So there's 4 parts for polymers. The first one is introduction. So the introduction yang macam ini, yang lain ni macam dia akan bercampur lah sikit. Because yeah. So first of all, polymer, what is it? It is a large molecule that is made up of many small repeating units. So those small units are called monomers. Okay, maksudnya ini macam benda yang lebih kecil, ini banyak-banyak ni akan buat your polymer. So they are linked by covalent bonds. So your monomer tu, itulah your basic molecular units, benda paling basic macam the brick. Okay, monomer is the house. Okay, so the process to form polymer is called polymerization process. Okay, so N is the number of monomers that you have. Okay, and this one, your polymer, ini menunjukkan that your monomer is connected to each other. Okay, ini repeating unit sebanyak N times. Okay, so you repeat your monomer A N times to form your polymer. So the repeating unit of your polymer yang ni, A is this. Okay, so that's how you need to know how to identify the monomer lah. Okay, contohnya if you have ethylene, your monomer, so you undergo polymerization, you will form your polymer polyethylene. Okay, so ini kan CH2 double bond CH2 kan. So bila sama-sama sambung, dia akan jadi CH2 CH2. This is your monomer. Lepas tu the next basic unit monomer is CH2 CH2 juga. So sambung je macam tu. Then you get your polymer. So this bracket nak menunjukkan yang this repeating unit goes on for N times. Okay, alright, so there are 2 properties for your polymers. So you have homopolymer. Kalau homo means same, so your polymer is made up of only one type of monomer, like this one. So ada A je, satu jenis monomer. Okay, contohnya teflon. If you look here, this is your monomer, CF2, CF2. Okay, kalau tengok sini, this is CF2, 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 CF2. So, benda sama yang repeat itself. One type of monomer only. So, the next property of monomer is, polymer is copolymer. So, co maksudnya, macam kalau co-ed means sekolah laki dan perempuan. So, copolymer means it is made up of 2 or more different types of monomers. So maksudnya it is not only just one monomer. So here you have Na, polymer A plus polymer B. Okay, and number of polymer A and number of polymer B. Okay, you polymerize them together and you will get this repeating unit of your polymer. Okay, so if you look here, we have 1,1-dichloroethene and chloroethene, satu je chlorine. So when you form the monomer, you can see that this is your first monomer A, which is 1,1-dichloroethene, and here you have the second monomer from chloroethene. Okay, so this polymer is actually called sarin. I don't know. So this is a type of wrapping film. This is the polymer used to make wrapping film. Okay, so there are 2 structures of polymers, tadi 2 properties. So you can have linear polymers. Linear maksudnya straight chain. Okay, lurus saja. So it consists of monomers that are linked in straight and long continuous chain. So it can be folded back, maksudnya boleh lipat balik upon themselves in random fashion it is recyclable. Why? Because it is soft and can be reformed when heated. So maksudnya bila awak dah fold dia macam mana-mana pun, bila awak heat up pun kan, dia boleh reform balik. Awak boleh dapat it in its original form. Okay, so this is how you will write your linear polymer. It is just straight chain, satu je. Okay, this is how it looks like when it is folded. Okay, so even macam ni kan, awak boleh dapat balik dia in its original form, this linear type polymer. But if you have cross-link polymers, okay, it means that cross-link tu maksudnya awak ada straight chain polymers that has branches. Okay, ni polymer dia ada branch. Okay, so these are the harder, more rigid, more elastic type of polymer if compared to linear polymers. So they do not soften when you heat them, so they will not reform to its original shape even if after heating. Okay, it does not soften upon heating, and it cannot be recycled lah. It is not recyclable macam linear polymer ni. Because of this branch, okay, dia dah jadi macam lebih complicated. So how it looks like this. You have here the linear polymer, and then another linear polymer, and you have this branch. Okay, so if you can see here, this is the long polymer chain that is cross-linked. Okay, cross-linked by branches X. So ingatlah yang cross-linked polymers ni, you have branches. Okay, next we have two types of polymers. We have the natural polymers and we have synthetic polymers. So natural polymers are those polymers that you find naturally, okay, daripada nature, okay, daripada contohnya kalau protein, you have our enzymes in our bodies, okay, hormones, hemoglobin in your blood cell, okay, benda-benda yang bukan awak buat, bukan manusia yang buat lah, okay, kita jumpa in nature. Okay, so a few examples of natural polymers are proteins, carbohydrates, and natural rubber. Okay, ada 3. So these are the examples. So for proteins, okay, they are built from amino acids. So kita dah belajar kan amino acids, so they are linked by amide bonds atau peptide bonds. Alright, so here this is our peptide bond. If you can see here, ni peptide bond ke? This is our amino acid, okay, as the monomer. Okay, so next we have carbohydrates. So carbohydrates, for example, like in starch you have amylose and amylopectin. Alright, so this is the structure of amylopectin, and it has this alpha-1,4 glycosidic linkages. I don't think you have to remember this structure because it's too complicated for you, but just know that the type of linkage lah, just be aware of it. So for amylopectin, it has the alpha-1,4 glycosidic and alpha-1,6 glycosidic linkages. So maksudnya instead of 1,4 dia 1,6 lah. Okay, I mean dia ada this combination. Okay, now we're going to look at the next type of example, which is natural rubber. So natural rubber or cis-1,4 polyisoprene. Okay, natural rubber, it is a polymer of this monomer 2-methyl-1,3-butadiene or isoprene. Okay, so ini adalah monomer dia. Kalau dia cakap polymer of, ini adalah monomer. Okay, polymer of this monomer. So here, kalau nampak N ni je, it means that N times of your monomer. So this is your monomer, isoprene. Okay, For natural rubber, this is our monomer. So when we polymerize it, okay, ini ulang banyak kali, repeat it for n times, we will get cis polyisoprene. So if you can see here, for natural rubber, your double bond in your natural rubber are cis configuration. Cis maksudnya it's on the same side. So here you can see that CH2 and CH2, they are on the same side. Okay. Okay, so natural rubber, it is soft, sticky, not strong, or elastic. So kalau natural rubber tu macam apa? I think it's like latex, you know. So it's soft, sticky. You can't really use it to like ikat apa-apa sebab dia sangat soft and sticky and not elastic. So not really the rubber yang kita guna in everyday tu kan. Itu adalah rubber yang sudah kena improve lah dia punya properties. So your natural rubber, how do we make it useful? It can undergo vulcanization process. So vulcanization process is when you heat your natural rubber with sulfur. Okay, so let's say we have soft rubber here, maksudnya our natural rubber. Okay, this is our natural rubber. Kita polymerize it, heat it with heat the rubber with sulfur atoms. Okay, so the sulfur atoms will become your branches. Okay, so here we have a long chain of polyisoprene, your natural rubber. Okay, cross-linked, maksudnya dia ada branch by sulfur atoms. So now your rubber is much more stronger than it originally was. Okay, so it undergoes this process called vulcanization process. Okay, natural rubber saja. Okay, next we have the synthetic polymers. Synthetic maksudnya dia adalah not natural, unnatural, it's fake, it's synthesized, it's made by humans lah. So they are prepared in industries, okay, maksudnya kat kilang, from your monomers that have gone through polymerization process. Okay, so we can classify our synthetic polymers by the method of preparation. Okay, your polymerization process. There are two polymerization process that we know of to make two types of synthetic polymers. Okay, so the first type of synthetic polymers is addition polymers. So since it's classified by the method of preparation, that means that addition polymers are obtained by addition polymerization process. Okay, that's the process. So apa kalau addition ni you've learned before, it means that daripada double bond kan, daripada double bond jadi carbon-carbon single bonds. Okay, from double bond jadi single bonds. That means that you're going to add something, right, without eliminating any small molecule. Okay, so for addition polymers, the empirical formula of your polymer is equal to the empirical formula of your monomer. Maksudnya they are made up of the same number of carbons and a same ratio of carbons or whatever atoms lah dalam awak punya compound tu, dalam polymer dengan monomer tu. Okay, so the examples are these yang saya highlight biru ni: polyethylene, polyvinyl chloride, PVC, polystyrene, polyisoprene, and Teflon. Okay, yang special, another hint for addition polymers is that you will use peroxide. Okay, ingat tak peroxide tu apa? Maksudnya awak ada ROOR. Yang ni, awak ada 2 O tu. Okay, these are the examples. Let's say to form the polymer polyethylene, your addition polymer here, you will use the monomer ethene. Okay, so in the presence of your peroxide, and you will get this polymer. Okay, so CH2 dia ulang balik je. Okay, ni patutnya ada sini N, right? So next, you can form your polychloroethene or PVC by using chloroethene. Okay, ini pun sama. Nanti awak letak bracket, letak N. Okay, so ini untuk buat polystyrene. And this is to make Teflon. Okay, right. Next, okay, is another type of synthetic polymer called condensation polymers. So maksudnya, you form condensation polymers by condensation polymerization process. Okay, maksudnya polymerization yang jenis condensation. Condensation kan, ingat tak awak buat apa? You will combine two big molecules, in this case your monomers, okay, with elimination. Okay, tadi tu addition tu without elimination. But here condensation with elimination of a small molecule. It can be water, methanol, hydrogen chloride, or even ammonia. Okay, in this polymerization process. So maksudnya awak akan remove something. Okay, so in this to make condensation polymers, you must have at least 2 identical or different functional groups in the molecule. Okay, so the first example is of condensation polymers is polyamides. Okay, you form polyamides, okay, when a carboxylic acid with 2 COOH groups, 2 carboxyl groups, react with an amine with 2 amino groups. Okay, so these are the examples: nylon 6,6, nylon 6, and Kevlar. Okay, on your right here, you can see okay, this is the monomer. If you can see this monomer here, okay, 6-aminohexanoic acid, you have an amino group and you have your carboxyl group. So ini N maksudnya dia monomer kan. So maksudnya dia bukannya ada satu je lah. Awak akan react this molecule with itself. So ini akan plus H2 and CH2 5 blah 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 blah. So maksudnya in this case, okay, for this reaction you are going to remove water. So tadi H2 tu kan daripada nitrogen from this monomer. Okay, this monomer and monomer react together under polymerization process. You will remove water. Okay, so you will remove water from your carboxyl group and remove 1 hydrogen from your NH2, your amino group. Okay, and then nanti dia akan sambung saja. Okay, when you sambung, you will get your polymer, which is nylon 6. Okay, and you will eliminate water. Okay, next here is the formation of Kevlar. So in the formation of Kevlar, you will remove HCl, okay, hydrochloric acid. So you will react your monomer. This is, yang ni contoh dia ialah 2 types of 2, bukan identical, 2 different, at least 2 different functional groups in the molecule. So ini awak react 1 monomer with 2 amino groups and 1 more with acyl chloride. Okay, tapi ni kita kira dia macam dia akan react the same way as carboxylic acid. So in this case, we will remove HCl. Okay, so we will remove HCl here. Okay, lepas tu sambung je nitrogen ni dengan C double bond O. So you will get your, what is this? Your amide linkage atau peptide bond. Ingat tak? So this is your polyamide, okay? Okay. Finally, for the formation of nylon 6,6, you are reacting a diamine, this specific diamine with this dioic acid. So ada 2 carboxyl groups. So here you will remove water. So maksudnya you can remove water from here. Okay. And then dia akan sambung. Kira macam plus banyak. Lepas tu akan remove N moles of water lah. And you will get your amide linkage, your peptide bond in your nylon 6,6. Okay. So ingat condensation of polymers, you will remove something. Okay. Okay. Next type of synthetic polymer is synthetic polymer by condensation polymerization is polyester. Polyester maksudnya poly banyak ester. Banyak ester. So for the formation of polyester, it is when you react carboxylic acid with 2 carboxyl groups. We're reacting with an amine with 2 OH groups. Okay. Amine with 2 OH groups. I will check this again because it sounds weird. Okay. I think it's alcohol. Alcohol. Okay. So for polyester, the repeating functional group in this polymer is ester lah. Obviously, polyester. So contohnya adalah, contoh popular yang awak kena tahu ialah dacron and terylene. Terylene. Okay, so here we have the formation of dacron. So when you react your carboxylic acid with 2 carboxyl groups here with your ethane diol, you will remove methanol. I think yang ni pun salah lah. Nanti saya check balik yang ni. I think I got this part wrong. I think this is ester. C-1O-OCH3. Okay. Okay, so you will remove your O, R with H. Okay. So basically OCH3 minus dengan H plus will form your eliminated byproduct, which is methanol. Okay. So here you will form the functional group ester in dacron. Okay. Okay. Yang ni pun you have this dicarboxylic acid. Okay. Reacting with a diol, so you will also remove water. Okay. So you will remove water and form terylene. This is your ester functional group in your polymer. Okay. Okay, dah habis dah. Last sekali, these are the uses of your synthetic polymers. Okay, ini awak baca je lah sendiri. Okay, ini PE, polyethylene. Awak boleh buat plastic bag, plastic film, wrapping film, container, drinking bottle, toys. Ini PVC untuk buat construction tools like pipe, door, window, floor tiles. Dia lebih kuat. Okay, PVC. Polystyrene, you know polystyrene kan, yang awak pergi cafe tu awak dapat polystyrene. They are containers, or it can be used in making CDs, DVD cases. Okay, bottles, disposable cutlery. Nylon 6, dia lebih kuat. Okay, it's used to make automotive gears, maksudnya kenderaan, and bearing. Toothbrush, strings for guitar, violin, threads, ropes, textiles. So maksudnya polymer ni dia quite strong lah. Dia benda yang awak boleh guna. These are the stuff that you use in your everyday life. Okay, ni Kevlar used to make combat helmets, bulletproof vest, gloves. Okay, Teflon to make your Tefal non-stick frying pans coating konon. Okay, Dacron to make synthetic fibers, bottles, Terylene to make fiber optic materials, clothing, ropes, and sails. Alright, so I think that's all. Okay, so that wraps up our last chapter for this final semester. Okay, thank you very much for tuning in. I hope you are hanging on. Okay, it's never too late, so keep on studying, keep on fighting until your final paper chemistry. Okay guys, jangan ada last paper syndrome. Kalau tak, nanti kita sedih. Okay, alright guys, bye. Thank you very much.